everyone, welcome back to your favorite channel guys. Good evening. I can see somebody was writing that I'm invincible. Okay, Sujata, Daksh, Srishti, Ridhima, Prabha, Lata, welcome back guys. Navjot, Abu Tahir, Manikandan, Sneha, Devarpan. So many of you have joined in. Great. Good evening, good evening. How are you? How is the preparation going on? मजा आ रहा है साइंस के लिए प्रिपेयर करने में? हाय पार्थ, पूजाल, भविष्यता, मनोज, रिया, सरिता, साई, तनीशी. Welcome back guys. Hey Neeraj. Sujata is saying great, preparation is going great. Good to know that. On a scale of 1 to 10, कैसा जा रहा है preparation? 10 on 10 जा रहा है? 5 on 10? If you really have to give a number to it, let's see. Hey Litika, Praveen, Priyanshi, Ritu, Charvi. Welcome guys, welcome back. I see a lot of you write 10 on 10. Just completed chemistry, 7 on 10, 5 on 10. Thankfully, सबका जो number है 5 से ऊपर है. It's okay, it's just the first day, right? 9, 10, 8, great. Books, okay, so no need to read a lot of books at this point of time. ये time majorly revision के लिए, okay? This is majorly for revision. Stick to NCERT, NCERT exemplar, and of course, our videos, Byju'S videos. Great. Good to know that. Yes, so this session is going to give you a vision, it's going to give you a direction on how to ace the exam. That's why we're meeting here again. We genuinely want to help you, right? We genuinely want you to be really clear about the complex concepts that are there. So ask and progress. Wherever you face any doubt, post your doubt over here in the comment section. Ask and progress. That's the drill for today. Hi Gauri, Shikha, Pooja. All right, Abhinetri. Good evening. Good evening, guys. Ready for today's marathon? Awesome. The preparation is going good. That's great. डर लग रहा है, bad, okay. डरना नहीं है. Don't be scared of this preparation. Don't be scared of the board exam. See, I know this is the preparation phase. You might be feeling anxious. You might be feeling a bit scared. But if you feel that you're feeling saturated at any point of time, just pause. Take a break. Take some time off. But then start afresh with double energy. Yeah? So if you think that, you're feeling confused, you're feeling maybe a bit scared of the exam and negative feelings basically, a quick 15-minute break is what you need, but then get back with double energy as I told you. Yes? Good evening guys, good evening. Alright, before we begin, you know the drill, right? You have to quickly confirm if this setup is working fine, you can hear me properly, see me properly. This video is working fine, so I'm going to write a 10 on 10. That's what we want the preparation to be. Yeah? Great. Awesome. Hi, Hari. Minakshi, Archana, Swami Aditya. How long is the video? Well, it depends. Perfectly audible, visible. Yes, we will be discussing everything. I can see you people are posting a lot of small concepts, important concepts out there. We will be discussing all of this today. This is a very, very important session, guys. Complete Term 2 Chemistry Marathon. We will be covering every topic today. And if at all you feel that you've missed on any topic, this class is meant for you for that context. Yes? I will be sharing all the formulas. All general formulas, don't worry. Great, Varna. I can see you people have posted loads of thumbs up. That means the setup is working absolutely fine and we can get started. So, by now you all know that we have two very important and two very interesting chapters in discussion, right? Very, very interesting chapters. We have carbon and its compounds and we have periodic classification of elements. Let's start with your favorite chapter, that is carbon and its compounds. Now, carbon is a very, very important element, right? I keep telling you, you are made of carbon, I am made of carbon, everything around us is made of carbon. Such an important element. In almost everything we find carbon. So, carbon को लेके थोड़े से basics clear कर लेते हैं. Let's understand carbon in great detail. So, the atomic number of carbon is 6 and the mass number is 12. When we have to write the electronic configuration, we are concerned with the atomic number. Atomic number will tell us the number of protons, and since it's neutral, that's also equal to the number of electrons. So, we have to place 6 electrons, right? For placing the 6 electrons, the K shell can accommodate 2 electrons and the rest 4 are in the L shell. This is how it's going to look like. Yes? So, electronic configuration for carbon 2, 4. Yes, Chevy. Correct. Now, I have a question for you. Clearly, you can see that 4 valence electrons are present. Valence electrons are the number of electrons in the outermost shell. Right? You can see 4 valence electrons are there. Please tell me, do you think is carbon stable? Keeping in mind that there are 4 valence electrons. And now when we talk about stability, what I want you to think is, stability in what context are we talking over here? Think on those lines. A quick yes or a no. What do you think? Is carbon stable? I see a lot of you write no, 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 no. And I see a lot of you write the reason as well. So, you people are absolutely right. It's not stable because the outermost shell is not completely filled. Yeah? Everybody wants to be like noble gases. Noble gases is like the topper of the class. Multi-talented. Alright, yes. So, for achieving stability, carbon is thinking what to do. So, the first attempt is to lose 4 electrons. Carbon is saying, okay, let me lose 4 electrons and see if this will make me stable or not. Now, the problem with this is, if carbon loses 4 electrons, it will be left with 2 electrons, yeah, and 6 protons. So, number of protons is not changing. Only electrons are lost, so only 6 minus 4 electrons leaves you with 2 electrons. This requires large amount of energy. That is why it is unstable. Requires large amount of energy. Now the second option is to gain electrons. So carbon thought, okay, let me try this out as well. Let me gain 4 electrons and see what happens. When this happened, nucleus felt really overwhelmed. Nucleus is like, itna kaam kaise hoga? I cannot hold on to the 4 extra electrons because now, after gaining 4 electrons, 6 plus 4, there are 10 electrons. Number of protons would be the same, right? So, nucleus is finding it very difficult to manage these 10 electrons, these extra 4 electrons. As a whole 10 electrons and extra 4 electrons. So, I want you to provide a solution. What is the solution? Carbon cannot lose electrons, cannot gain electrons. According to you, what is the solution then? Let's see. Shearing, yes. So, since both these cases are unstable, carbon moves on to the third option, that is shearing. So, carbon shears its electrons to achieve stability. So, yes, shearing is definitely occurring even at the atomic level, and this is how the atoms are shearing electrons to become stable. Now, when the electrons are being sheared, covalent bonds are being formed, and the compounds which have covalent bonds are known as covalent compounds. Simple. Covalent compounds have covalent bonds. Covalent bonds are formed by shearing of electrons. Yes? Great. All right, noted. Correct, correct, correct. Covalent bonds are being formed. Now, over here, you can have a single covalent bond, you can have a double covalent bond, and you can have a triple covalent bond. Based on this, actually you will be drawing the electron dot structure. They can ask you to do the same. When we talk about a single bond, 2 electrons are being shared. When we talk about a double bond, 4 electrons are being shared. When we talk about a triple bond, 6 electrons are being shared. So whenever we talk about the electron dot structure, it is going to represent only the valence electrons using dots or crosses. We are just concerned with the valence electrons, that's it. Okay, for hydrogen it's 1, for both, 1 for this atom, 1 for the other hydrogen atom. Oxygen, what is the configuration? 2, 6, right? So 6 valence electrons, and you can clearly see 6 valence electrons on the screen. Nitrogen, atomic number 7, 2, 5. So 5 valence electrons. Basically, over here, when electron dot structure is being made, we are just making the use of valence electrons. Is this clear? Perfectly clear, because this is where you people can make a mistake while drawing the electron dot structure, thinking that all the electrons are involved. All are not involved, only the valence electrons. Give me a quick thumbs up. A quick thumbs up that yes ma'am. Let the examiner give us any question. We will be drawing the right electron dot structure for that. Show me some confidence over here. Great. All right. So, let's draw the electron dot structure of methane. What is the formula of methane? Quickly. You have to quickly keep replying to my questions. I'm going to ask you a lot of questions. And especially for the ones who said, ma'am, 10 on 10 preparation. Shriram said CH4 and then everybody is saying the same. Okay, CH4. Now, for carbon, what is the atomic number? 6. Configuration 2, 4. Hydrogen 1. So carbon is going to share 4 electrons, hydrogen is going to share 1. So we have 4 hydrogens sharing 1 electron each, and this is how the structure is going to be formed. This is how the electron dot structure is going to look like. See how beautifully they are sharing the electrons. Yeah? Alright. Now talking about the versatile nature of carbon. Why do you think carbon is versatile, and what do you think leads to the versatility of carbon? Why do you think it's carbon? Ma'am, Hindi mein padhao. See, some of you are saying Hindi, some of you are saying English. I'm going to mix both. I'm going to speak in Hindi also. I'm going to speak in English also. Hindi mein bhi baat karenge, English mein bhi baat karenge. Dono mein baat karenge, because I see some of you saying, ma'am, stick to English. Some of you are saying stick to Hindi. Chemistry will still be chemistry, guys. Let's just be very focused right now. Alright, coming back to this, I see a lot of you writing about catenation and tetravalency, the reason behind versatile nature. Alright, why is carbon so multi-talented? You are giving the right reason. Correct. Yes, it is forming a large number of compounds. So tetravalency, as you people are saying, and catenation leads to the versatile nature of carbon. Tetravalency, tetra means 4, right? So 4 valence electrons are there, valency is 4, and it's able to form so many different types of compounds. Yeah? Hey Kripa. Yes, Sangeeta, absolutely right. So when we talk about catenation, it's the self-linking property. See over here, carbon is linked with another atom of carbon, which is linked with another atom of carbon, and this is how long chains are being formed. Yeah? So you are aware of these 2 very important points. If you've seen the previous year question papers, a lot of questions are based on this concept. And I can see you are very much aware of this. Alright, so silicon also shows the property of catenation. We've discussed a question regarding this, right? Based on this, yesterday we discussed how silicon was also showing catenation, but to a lesser extent as compared to carbon. So, silicon can show catenation up to 7 to 8 silicon atoms. Extent is less, but yes, if they ask you, can you name another element that shows catenation? Go ahead and mention silicon. Yes, Yes, Venkata, we are going to cover that too. We'll talk about everything, all important concepts, don't worry. Alright, coming to allotropes of carbon. So these are the different forms of carbon, right? We've got diamond, graphite and fullerene. Now what I want you to write down over here is quickly tell me one use of all these three allotropes. Diamond, graphite and fullerene. Any one use. Quickly. Let's see who's going to be the first one to answer this. Diamond, jewelry, correct. Graphite, conduction, pencil. Diamond ornaments. What about Buckminster fullerene? Treatment of cancer. Correct, correct, guys. Yes. Yes, diamond is really hard. In fact, it's so hard that you need a diamond drilling machine to actually drill it, actually cut it. Correct. Alright, out of these three, if I have to ask you कि कौन सा allotrope है जो conduct कर सकता है electricity? Quickly. Yes, Charvi, absolutely right. The chat box is flooding with one word, that is graphite. Alright, so you people know about the uses. Now, since there are different forms of the same atom, right, they basically are having different physical properties because they have different arrangement of atoms. Clearly you can see over here the arrangement of carbon atom is very different in each case. All these three structures look very different, so they have different physical properties, but essentially they all are atoms of carbon. So they have the same chemical property because they are made from atoms of the same element. In this case, it is carbon. So remember this because they can definitely give you a question based on this when it comes to comparing the chemical and physical properties of the allotropes of carbon. If till here everything is clear, a quick thumbs up. So I'll keep asking you in between if the concepts are clear or not. Quick thumbs up that yes ma'am, everything crystal clear till now. Alright Verma, Gitanshu, Shereen, Bhagya giving me loads of thumbs up. Great. Yeah, slowly we'll cover every bit, don't worry. Now, let's talk about hydrocarbons. But before I talk about hydrocarbons, what do you think are hydrocarbons? Quickly tell me this, hydrocarbons hote kya hai? What are hydrocarbons, guys? And no need to mug up. Just use your logic. My question has the answer hidden in it. Hey Lata, we're going to talk about periodic as well. Stay tuned. Contains carbon and hydrogen only, yeah. So hydrocarbon would have hydrogen and carbon only, right? Very simple. So it can further be divided and we can have saturated and unsaturated hydrocarbon. Saturated hydrocarbon bhi ho sakta hai, unsaturated hydrocarbon bhi ho sakta hai. And what's the difference? When we talk about a saturated hydrocarbon, it is going to have a single bond between carbon-carbon atom, as you can see over here. So this class is known as alkanes. For example, ethane. Give me another example of an alkane quickly. Quickly guys, yes, saturated. Yes, Khatam. Okay, your name is Khatam, Tata, bye. Someone in the chat is named as Khatam. Alright. Hexane, propane, methane. Methane, butane. Ethane, correct. You know about alkanes. Coming to unsaturated. So, if there are double bond present between carbon-carbon atom, this class is known as alkenes. For example, ethene. And my question to you is, quickly give me an example of an alkene. Any example of an alkene? Propene, butene, ethene, pentene. Alright. Now coming to the third one. If there are triple bonds between carbon-carbon atom, we call it alkyne. Example, ethyne. Your turn to give me an example. Butane, pentane, hexyne. Great. All right, all right. So, hydrocarbons. We have alkanes, we have alkenes, and we have alkynes. You people wanted to have this topic again, so we've put this over here about structural isomers. Now look at these two structures and count the number of carbon atoms, count the number of hydrogen atoms. In the first case, you will see that 4 carbon atoms are there and 10 hydrogen atoms. In the second structure also, you will see 4 carbon atoms and 10 hydrogen atoms. One is a straight chain, one is a branched chain. But clearly, what you can see is that they have the same molecular formula. Though they have different structures, they have the same molecular formula, and इसको हम एक term देते हैं which is isomers. So compounds having same molecular formula but different structures. So they have same molecular formula but different structures, and this phenomena is known as structural isomerism. Correct. Absolutely. All right. Yesterday also we discussed a question on this structural isomers of pentane. We asked you how many isomers are there. You were a bit confused. Some were writing 5, some were writing 3. So we thought we'll pick this up. We'll actually show you the structures here. So pentane, pent basically means 5 and ane means it's an alkane. So clearly carbon-carbon, single bonds are present. That means it's an alkane of 5 carbon atoms. So this is the first structure of the isomer, straight chain. Over here we've done one branching, over here we've done double branching. So these 3 are structural isomers of pentane, wherein you will find that all of them have the same molecular formula, which is, that is something that you're going to tell me. What is going to be the structural formula? Tell me about the structural formula of pentane, molecular formula. What is going to be the molecular formula? Quickly. Pentane, what's the molecular formula, guys? Let's see. Gurang is saying C4. C5 tak to clearly visible hai. C5H12, C5H10, C5H12, C5. Someone has written C5H12 a lot of number of times. Great. C5H12. Yes. Alright, now coming to functional groups. So functional groups confer specific properties, and this is another very important topic, and a lot of questions are based on this topic. So it's very important to see what functional groups are there in your syllabus, what you need to cover. So pay a lot of attention to this topic. Okay, functional group, you will only tell me, since it's a revision class, you have to tell me which functional group is this. What is being shown to you? Alcohol, correct. Okay, now tell me about this. Quickly, you have to be really quick in typing. Which functional group is this one now? Aldehyde, no. Acid, carboxylic acid, all right. What about this one? Aldehyde. Arey, har mein aldehyde. It's like, you know, just learning one and putting it on all the options ki aldehyde hi hoga. Kahi to sahi hoga. Halogen, correct, correct, correct. Okay, what about this? And don't write aldehyde again. This one, quickly tell me. Someone is again writing aldehyde in all the cases. Okay, but most of you are saying ketone. In fact, almost everyone is saying ketone. And finally, this one. What about this one? Tell me. Aldehyde, finally, the one who's been trying to write aldehyde from the very beginning. So yes, now you are finally right. But don't have this approach in the exam, yaar. Exam में ऐसे मत करना. By chance कुछ true and false के 3, 4, 5 आ गए, सब में true लिख दिए कि कोई तो होगा, या सब में false लिख दिए तो कोई तो होगा. Don't have this approach. It's so easy. Just understand it. Yes, this is aldehyde. All right. Now, out of these functional groups, some of them are very flexible. Some of them are very particular about certain things. So, alcohol and halogen. They are very flexible functional groups. They are like you can place us anywhere across the chain. We are happy if you put us somewhere in the middle, maybe at the terminal, anywhere. They can be placed anywhere. But the rest three have specific positions in the compounds. When we talk about carboxylic acid and aldehyde, they are always present at the end of the chain. Always present at the end. And there is a reason. Look at this carbon. When you look at this carbon, clearly you can see that 3 bonds are already there. It needs 1 more only. If you will place it somewhere in the middle, it will have 5 bonds. Obviously, it cannot be there in the middle, right? It has to be at the end. Same goes for aldehyde as well. 3 bonds are already there. It requires 1 more. Yeah? So, carboxylic acid and aldehyde always at the end. And look at ketone. Ketone needs some help. Ketone wants to be there in the middle. Someone on the left, someone on the right. Correct, middle seat. Yes. So, there you go. Ketone will always be present in the middle of the compound that you see, middle of the chain. Now, when you look at this, understand the position because they can ask you to identify. Understand which functional group is placed where. That is really important. If this is absolutely clear to you, give me loads of thumbs up, loads of smileys in the comment section that yes. Now, if you give us any question to ask us about the position of the functional groups, we'll be able to answer really quickly. Great, I can see loads of thumbs up. I can see some of you were there yesterday as well. Thumbs up, smiley, alternate. Nice. Good to know you remember. Crystal clear. Awesome. Alright, now coming to homologous series. It's a series of compounds in which the same functional group is substituting for hydrogen. Hydrogen को हटाकर functional group place कर दिया है. And then we have various members. And this series is known as homologous series. For example, we've taken the series of alcohol over here. Methanol, ethanol, propanol. Don't be scared when you see C2H5. It's nothing but CH3, CH2OH or C3H7OH. It is CH3, CH2, CH2OH. This is clear to you, right? So, it's just the condensed form, right? Carbon को साथ में कर दिया, hydrogen को साथ में, but it's the same. Now, they have the same functional group. OH, OH, OH. Right? So, the same functional group is substituting for hydrogen. What do we mean? Substituting for hydrogen. If it was initially, say, CH4, this H is being removed and OH is being added. Yeah? So, there you go. You have the same functional group substituting for hydrogen in a carbon chain, and all these are members of alcohol series, right? Okay, now certain characteristics are there. First of all, adjacent members differ by CH2 group. For example, if we take the class of alkanes, we've taken the family of alkanes, we have methane, ethane, and we have propane. Now, from methane to ethane, what is being added? CH2. From ethane to propane, what is being added? CH2. So, every member, adjacent member, differs by a fixed unit which is CH2. Now, you are going to tell me the next one. What is going to be the mass difference? I've told you the first point that adjacent members CH2 से differ करेंगे. Now, you tell me the difference in mass between adjacent units. A quick reply. Come on guys, buck up. Quick replies. Great, I see a lot of you right. 14, you correct. Correct. Yes, and this brings us to the next point, that the difference in molecular mass of any two adjacent member is 14U. How is it 14U? We are talking about CH2, carbon, hydrogen, 12, 1, 1. The mass is right. Just add them. Comes out to be 14. I hope you know why this is 14, because somebody was asking why 14. So there you go. This is how we have calculated. Yes, correct. So, because the molecular mass of CH2 is 14U. Now, they can be represented by a general formula, right? For alkanes, the general formula is CnH2n plus 2. If you place n equal to 1, you will get the first member. N equal to 2, you will get the next member. So, for n equal to 1, it is going to be C1H2 into 1 plus 2, which is CH4. Similarly, you can calculate for the rest. Alkenes, general formula is CnH2n. What is going to be the first member? My question to you is this. I've told you the first member of alkane family. Now it's your turn to tell me the first member of alkene family. The formula. Devarpan has already answered. Devarpan was the first one to answer. Though right now the chat is flooding with the first member, which is absolutely right. Correct. Yes, it has to begin with n equal to 2. Why not n equal to 1? If I place n equal to 1, so this becomes C1H2 into 1, which is 2. So it is like CH2. The valency is not satisfied, right? So this is incorrect. So n equal to 2 brings us to C2H4. Correct, guys. Great. Awesome. Now tell me the general formula of alkynes. You have to tell me this one. What is the general formula of alkynes, guys? Let's see who's going to write this one. Vaishnavi says CnH2n minus 1. I see somebody write CnH2n plus 2. Then what is for alkenes? CnH2n minus 2. Correct. So CnH2n minus 2. This is for alkynes. Quickly tell me the first member of alkyne family. Come on. Jaldi se bata do. First member of alkyne family will be. Yeah, it cannot be n equal to 1. See, if I put n equal to 1 over here, this becomes C1H2 into 1 minus 2, which is C1H2 minus 2, which is 0. So it becomes only carbon. So yes, not possible. It has to be 2, C2H2. All right. Great. Next, members show a gradual increase in physical properties with increase in molecular mass. Let's take the example of these alcohols. From methanol to ethanol, CH2 is being added, right? So obviously, we can see that there is an increase in molecular mass. Because of this, the physical properties are also going to increase as you go from one member to the next. Right, for solids, melting point would go on increasing. For liquids, boiling point would go on increasing. Yes? Correct. So there's going to be an increase in physical properties like melting and boiling point. Alright, so carbon and its compounds, we've got an overall idea about this. We have an overview about this. I know you people are constantly asking for periodic classification. So let's get started with periodic classification. Now yesterday you told me that Dauber-Reiner and Newland is very easy, ma'am. We want to start with Mendeleev. So there you go. We're starting with Mendeleev over here. So Mendeleev said that the properties of elements are a periodic function of their atomic masses. Clearly you can see increasing atomic mass over here. Yes? Now the first thing to note about this table is that everything is being arranged on the basis of atomic mass. How many periods and how many groups are there? Quickly, you have to reply really quick. Yes, Navalam, we'll come to that as well. Correct, so 6 periods and 8 groups. Not 7 periods, guys, 6 periods and 8 groups. Alright, so there were a lot of achievement of Mendeleev's periodic table, and this is a very common question that is being asked in the exam, that what are the achievements of Mendeleev's classification? What good Mendeleev has done. You know, this table, Mendeleev's table, was the start of a great thing in chemistry. Do you agree with me? So let's discuss. Yes, I can see a lot of thumbs up. Let's discuss the achievements first. Now, over here at some places you'll notice that the sequence is inverted. Now this can be a defect also, and this is an achievement also. It depends how you present it. In case we're talking about achievement, how is it an achievement? Well, let's see. Since the sequence is inverted over here, elements with similar properties can be grouped together. They can be placed together, right? So this, in this context over here, can be considered to be an achievement. We'll come back to this point when it's being covered in defect as well. Alright, now he left some gaps and he was really confident, just like you people. I see a lot of confidence in you. Mendeleev was also really confident that these gaps are not defects. They are not at all defects. They are basically for the elements which are yet to be discovered. And at that point of time, he didn't know which elements would be discovered, so he named them as Eka boron, Eka aluminium and Eka silicon. Eka means first or one. So later, the elements were being discovered named as scandium, gallium, germanium, which were placed perfectly fine there and matched the properties as well. So Mendeleev's periodic law could predict the existence of some elements that had not been discovered at that time. I mean, imagine how great this is. Something that's not even there, he could actually predict, he could actually be very confident about it as well. That, you know, let's leave some space and some elements would definitely fit in here. And he also told what properties these elements would be having. Great! Visionary, correct. Alright, now the next one is later on, when noble gases were being discovered, they could easily be placed without disturbing the rest of the elements, without disturbing the rest of the arrangement, which is a very good achievement. So if these three achievements are perfectly clear to you, give me 3 thumbs up in the comment section. Quick reply. 3 thumbs up in the comment section to tell me that yes, if this question comes in the exam about the achievement, you will be able to answer this absolutely fine. Great, awesome. Alright, now coming to limitations. First of all, no fixed position was given to hydrogen in the periodic table. Hydrogen को कोई भी fixed position नहीं मिल पाई. Group 1 and Group 7 दोनों के elements से match हो रहे थे. So, this was the first limitation. Secondly, isotopes of elements basically were discovered later, which violated the law. Isotopes would have same atomic number, different masses, right? If these atoms are having different masses, they'll be placed at different places. Obviously, if they're being placed at different places, in a way this would mean that the same element is being placed at multiple places, right? Because the atoms of these elements would have different masses. So, this kind of made no sense. Later on, it just violated the law. Correct, not uniform. No, not about being uniform, it's just that one element needs to have one particular spot, right? Correct, yes. Now third one, the trend of increase in atomic mass was not regular. See over here, cobalt and nickel, right? Clearly you can see that in this case, mass is not increasing uniformly. We have something with a higher mass placed first, and that's why, hi Mayuresh, okay. So that's why obviously this is not uniform. But when we decide a basis for something, we want it to be, you know, really constant and have a uniform flow. Yes? Great. So if these 3 limitations are perfectly clear, you know what to do. 3 thumbs up or 3 smileys or 3 laughing faces. Quickly. Jaldi se. Yes, yes, I remember you. Alright, so then comes modern periodic table, which is completely based on the atomic number. Now the basis is atomic number. What is the modern periodic law? It says properties of elements are a periodic function of their atomic number. Why are we taking atomic number, guys? You are going to tell me this. Why are we taking this as the basis, atomic number? एटॉमिक मास जब मेंडलीव ने बनाया तो अच्छे खासे अचीवमेंट्स थे. व्हाई आर वी शिफ्टिंग टू एटॉमिक नंबर? Quickly. Uniform, constant, increases by 1. Correct, correct. Increases by 1. Yes, see, over here you can see it's 1, 2, 3, 4, increasing by the same number, that is 1. And that's why we have such a beautiful table, and this modern periodic table is the basis of entire chemistry. I think entire chemistry is in this beautiful table that we have. Yes? Great. Now coming to trends, which you people have been asking from the beginning of the class, that let's discuss the trends. So here we are with the trends, and you people have to participate when I say that we'll be discussing about trends. Yeah, so be really quick in replying, because I can see some of you replying then and there, but some of you are waiting for others reply. जल्दी जल्दी ट्रेंड करेंगे, ठीक है? First trend is valency. Now when we talk about valency, it's the combining capacity of an element. For valency, you need to know about valence electrons. Don't get confused between the two. Valency is separate, valence electron is separate. They are linked in a way, but they are not the same. Valence electrons basically are the number of electrons in the outermost shell. So I can write a 1, 2, 3, 4, 5, 6, 7, 8. What is this? This is valence electron. Group 1, 1 valence electron, group 2, 2 valence electron, group 13, 3, group 14, 4, and so on and so forth. Now, from there, how are we calculating the valency? If it's 1 valence electron, valency is 1, 2 valence electron, valency is 2, 3 valence electron, valency is 3, 4 valence electron, valency is 4, everything sorted till here. But after that, what are we doing? For calculating the valency, we are doing 8 minus the number of valence electron. So 8 minus 5 gives you 3. 8 minus 6 gives you 2. 8 minus 7 gives you 1. 8 minus 8 gives you 0. So this is how we have written the valency over here. I hope this is clear to you, and clearly now you can see that valency is first increasing and then decreasing. Now sometimes they ask you the trend of valency, and what you do, you end up writing that it increases. क्यों? क्योंकि आपने उसको valence electron समझ लिया. Because you confused this with valence electron, and you tend to write that it increases. But no, we're talking about valency, not valence electron. Valency first increases, then decreases across a period. And down the group, pick up any group, you will notice that the number of valence electron is the same. Therefore, the valency is also same. So, it remains the same down the group. If this first trend is crystal clear to you, give me loads of thumbs up that yes, we can move on to the next trend now. Quick thumbs up in the comment section if this is clear. It's okay if you're late, not a problem. You have some days in hand. You can always go back and watch the video again. I see a lot of interesting emojis actually. Great. Let's move on to the next trend now, which is atomic size. See, most probably they'll ask you application based questions on these trends. So be very attentive right now. We are discussing every trend in great detail, understand them properly, so that if any application based question is there, you are able to answer. Now, what is atomic size or atomic radius? It's the distance between the center of the nucleus and outermost shell of an isolated atom, right? Down the group, what is happening? Effective nuclear charge is decreasing, right? Effective nuclear charge अगर decrease हो रहा है तो attraction भी क्या हो रहा है? Decrease हो रहा है. Attraction अगर कम हो रहा है तो electrons दूर दूर जा पा रहे हैं. That is why size is increasing. But what happens across a period? Across a period, effective nuclear charge is increasing. That means the attraction is increasing. They are wanting the electrons, right? They want to have the hold of the electron. So atomic size is in a way decreasing. Remember this, down the group, size is increasing, left to right across the period, size is decreasing. Yes? If this is absolutely clear, you know what you have to do. You have to give me any interesting emoji in the comment section. Yes, Pankaj, correct. Yes, Sanjeev, all the trends. Interesting emojis. Positive, interesting emojis, I would say. Don't show me scared faces. Great. All right. Okay, Angel. Victory. All right, all right. Let's move on to the next one, which is metallic character. Now, when we talk about metallic character, it's basically linked to the tendency to lose electron. Now, metals would want to lose electron and form cations, right? So, they are electropositive in nature. Metals are electropositive in nature and they are basically losing electrons during bonding. Clearly, you can see over here that a cation is being formed after the electron is being removed. Now, more this tendency, जितनी ज़्यादा ही tendency होगी, जितना easily electron lose हो पाएगा, उतना ज़्यादा metallic character. More the tendency to lose electron, more will be the metallic character. Metals want to lose electron. Simple. They want to lose electron. If they are able to lose electron easily, their metallic character would be more. Cation would have a positive charge, anion would have a negative one. Now, left to right, kya hoga metallic character? We're going to come to that. So, first let's see down the group. You're asking about left to right, we'll come to that as well. Down the group, first see what happens. Just remember one thing, down the group, effective nuclear charge is decreasing. If you know effective nuclear charge, the trend of effective nuclear charge, you'll be able to answer most of the questions. Down the group, effective nuclear charge is decreasing, attraction is decreasing. So, electron can be removed easily. Nucleus has some positive charge, right? Electron has a negative charge. There is some attraction. If this attraction is less, in that case, electron can be lost easily. That is what is happening down the group. So, metallic character is increasing. The tendency to lose electron is going to be more. Across a period from left to right, what is happening? Effective nuclear charge is more. Nucleus is not letting go of the electron. Nucleus wants to hold on to the electron. So, what is happening to the metallic character? It is decreasing. Easy way to remember. Look at your periodic table. On the left side, you see a lot of metals, right? On the right side, you see most of the non-metals are placed on the right side. So, obviously, metallic character is going to be more on the left side. Okay, just a way to remember, guys. Now, can you guess what is non-metallic character? Quickly, some of the comments are very entertaining over here. I've told you about, yes, I can see the magnet. Alright, so, what is going to be non-metallic character? If metallic character is like the tendency to lose electron, non-metallic character is like the tendency to, you have to complete it. Vaishnavi says gain electron. Alright, so we agree with her. Tendency to accept or gain electron to form negative ions is basically telling you about the non-metallic character. अब जितनी ज़्यादा tendency उतना ज़्यादा non-metallic character. So, more the tendency to accept electron, more will be the non-metallic character. And see, they are forming anions. They have a negative charge. Electron has a negative charge on it, right? If electron is gained, overall charge is coming out to be negative. If electron is lost, overall charge is coming out to be positive. Great. All right. So, let's see what's going to be the trend of non-metallic character. Now, down the group, what is happening to effective nuclear charge? It is decreasing. That attraction is decreasing. Electronegativity is decreasing, which is the tendency to attract the shared pair of electrons. So, this tendency is also decreasing. So, what is happening to non-metallic character? That is also decreasing. Left to right across a period, what is happening? Effective nuclear charge is increasing. Tendency to attract the shared pair of electrons is going to increase, electronegativity is going to increase, and non-metallic character is also going to increase. And you'll find a lot of non-metals on the right side. Yeah? Great, awesome. A quick thumbs up if metallic and non-metallic character is crystal clear. I know you people will post some different emoji, some interesting emoji. Quick reply. Nice. Great. All right. Awesome. Let's move on and just summarize all this, because after this, you're going to apply this knowledge. You're going to solve some questions based on this knowledge. Yeah. So let's quickly summarize these trends before you have to apply. Left to right across a period, valency first increases and then decreases, but down the group it remains constant. Atomic radius across a period is decreasing and down the group it is increasing. Metallic character is decreasing across a period, it's increasing down the group. Non-metallic character is increasing across a period and decreasing down the group. Now they are not going to give you a very direct question. They'll give you really application based questions where you have to think. So let these trends go in, absorb these trends, put them in your mind perfectly fine, because now you have to apply this knowledge. Yeah, it's time to apply knowledge and solve some important questions. So if till now everything is crystal clear, the trends are fine and you are very confident that yes ma'am, you just give us the question and we are going to post the answer really quick. Give me loads and loads of thumbs up that we are all set to solve some really important questions together. Let me see how confident are you feeling. Yes Lata, same. Great. Let me see how confident are you feeling, guys. Come on. Buck up, we're about to solve some important questions together. Nice. Let's start. Let's get started now. I'll tell you why I asked how confident are you feeling. Now that you're feeling really confident, this means that I can expect right answers from you. So I want you to get in this habit of participating, post all the answers, and let's see. जो आप बोल रहे हो, जो आप claim कर रहे हो that yes we are very confident ma'am, just show us the question, क्या वो सच में सही है? Are you able to actually answer all the questions quickly and correctly? Great. So the first question is right in front of you. The question says, state the reason why carbon can neither form cations or anions but forms covalent bonds. We've picked up the questions that are repeatedly coming in your exam year after year. These questions are there. That is why we want to discuss these, so that when you have to write the answer, you know what to write exactly. So maybe you feel I know the answer to this question, maybe you feel I have already done this question earlier. In that case also, look at the solution, try attempting it, post your answer over here, just master these important questions. Okay, I can see that. Alright, the second part is write the structural formula of C6H6. Structural formula basically means you have to draw the structure. Okay, we'll start with the first part and you are going to answer this one. State the reason why carbon can neither form cation or anion but forms covalent bonds. Why cannot it form cation? We just discussed, we started the session on this note. Cation क्यों form नहीं हो रहा? Correct, yes. Anion and cation, unstable structures, yes. So we discussed about electronic configuration of carbon, that is 2,4. 4 valence electrons are there, right? Now if it has to gain or lose, ultimately it's leading to instability. For example, if it's losing 4 electrons, only 2 electrons are left, and this requires large amount of energy, as we just discussed, right? And this is going to be unstable. If it has to gain, in that case, nucleus is finding it difficult to hold on to the extra 4 electrons. right? A total of 10 electrons are there, extra 4 electrons are there. Again, it's coming out to be unstable. Therefore, it's basically sharing the electrons with other carbon atoms or with other atoms of different elements to form covalent bonds. For example, we discovered the bond formation of methane. Ma'am, when is Menti? Menti is going to be right after this, guys. Yes, it leads to instability, Kashfi, correct. So that's why it's sharing electrons like this. And finally, this is how you have to present your answer. Now, this is the most important part. Every time this slide comes, this is like the marking scheme we are telling you. This is how the teacher who's going to check your answer sheet will be marking you basis your answer. So pay a lot of attention when this screen comes where the marking scheme is there. This is how you have to present. Sometimes you know everything, you have the proper knowledge, but you're not able to deliver it fine. You're not able to write the answer properly or present the answer properly. That is why we are sharing this with you as well. So, carbon cannot form cation because the removal of 4 electrons would require large amount of energy, and it cannot form an anion because it's going to be difficult for the nucleus with 6 protons to hold on to 10 electrons, and therefore it ends up sharing the electrons to form covalent bonds. So 1 mark for this and 1 mark for this. Overall, don't give just one answer that unstable structures are being formed. You have to be really specific. Why not a cation and why not an anion? Next part of the question, write the structural formula of C6H6. What is this C6H6? Quickly tell me the name. Of course, you cannot draw the structure and tell me, but even if you will be able to tell me the name, I'll understand that yes, you have understood what the C6H6 is and you will be able to draw the structure. Abu Tahir ne already answer de diya hai. Dipali, Naresh, and then a lot of you writing benzene. Correct. So, this is how the structure looks like. You can also draw it like this. See, over here, this is also correct. Alternate double bonds, alternate double and single bonds are there. Yes, correct. C6H6, yes, 6 carbon atoms, 6 hydrogen atoms. And there you go, you just got another mark. Simple. Question number 2, and a pole is going to appear in front of you. You have to mark the answer over there. The question says, on the basis of electronic configuration of X, 5 is the atomic number, 11 is the mass number. The group number and period number of X is, your 60 seconds start now. A pole is going to appear. You have to figure out the position. Basically, group number and period number is nothing but the position. Figure out the position of X, whether it's going to be in group 15, period 2, or it's going to be in group 13, period 2, or group 9, period 5, or group 13, period 5. Which is going to be the correct option? Even if the poll is not appearing, you can always post your answer over here. So 2 places you have to post the answer. Poll also and chat box also. कोई बात नहीं, poll अगर नहीं आ रहा, chat box is there, right? I can see what you people are posting. I see a lot of you are posting for B. अच्छा. Some are saying A, some are saying C. D कोई नहीं बोल रहा. B बहुत लोग बोल रहे. Many of you are saying B. Last 5 seconds to post your answer quickly. Who is this crying? Sending crying emojis. See, in case you don't know the answer, we will be discussing that. Don't worry. Alright, time's up. Let's see. When we talk about X, this 5 is the atomic number. 5 protons, 5 electrons. So 2, 3 will be the electronic configuration. Now, number of shells can easily be known by the number of shells are basically telling you the period number. So, period number can easily be known by knowing the number of shells. You have K shell, you have L shell. How many shells are filled? 2. So, period number is 2. Now, about the group number, you have to look at the valence electrons. So, 3 valence electrons are there, right? So, 3 plus 10 will give you the group number, that is 13. So there you go. The correct answer was option B, as most of you said, group 13, period 2. Now you know the category of this question. They might change the atomic number and mass number and give you any element. Approach will remain the same. Yes? Approach आपकी वही रहेगी, guys. How many of you got this one right? A quick thumbs up in the comment section to tell me that yes, we got this answer absolutely right. Let's see. So many of you are raising your hand in the comment section. Flags चल रहे हैं, victory sign आ रहा है. You people are so confident. बिल्कुल calm down state में हो, which is the best thing. Great. Someone got a wrong answer also. That's okay. I hope now you've understood where you made a mistake. You got confused. But now you've understood. See, that is the entire purpose. Make as many mistakes as you want to right now. Where are you flying, Mukesh? Hey, Arpit, post the next answer. Alright, so the next question is right in front of you. Again, it's a poll question. If the poll doesn't appear, post your answer over here. Assertion, reason kind of a question. Okay. Assertion is following are the members of a homologous series. These are the members. Reason is a series of compounds with same functional group but differing by CH2 unit is called a homologous series. Your time starts now. So basically in this question they've given you two statements. One statement is in assertion, one statement is in reason. First check whether these two statements are true or false. Okay. If they are true, then check whether the statement given in reason is the correct explanation for the one given in assertion or not. This is how you have to approach such questions. So A and R over here basically means assertion and reason, okay? I see a lot of you post one common option. I'm going to reveal the option really soon. Let the last 10 seconds also get over and then I will reveal the final answer. Alright, last 5 seconds left, guys. At least try it out. See, at the most क्या होगा, question गलत हो जाएगा ना. At the most you will end up giving the wrong answer. But that's okay. This is just a preparation phase, right? These days that we have in hand, we are bound to make some mistakes and we need to rectify them. If you will not attempt, if you will not try, if you will not participate, you will not even know whether you knew the answer at the first place or not. Alright. A lot of you are saying A. Well, let's cross check this one then. Series of compounds in which the same functional group is substituting for hydrogen in a carbon chain is your homologous series, right? Clearly, as you go from one member to the next, CH2 is being added, right? From here to here, then from here to here. So, both these statements are very much true and the reason is the explanation. It's the correct explanation of the assertion statement. So, well done. How many of you got this one right? I'm sure I'm going to see a lot of victory signs now. Yes, Navalam, it's A. You've highlighted it. Great. Yes, yes, clapping signs as well. Awesome. Let's move on to the next question, guys. Let's see what the next question is. Compare the following elements as per the characteristics given in the bracket. Okay, you have to think about this one. Understand the question. Many of you fail to understand the question sometimes. See, the question is very, very simple. In case you feel ki samajh nahi aa raha, read it again. You have to compare the elements. They've given you two elements in each part, A, B, C, right? Basis the characteristic which is given in the bracket. So magnesium and phosphorus, you need to compare them on the basis of atomic radius. Lithium and fluorine on the basis of electronegativity. Boron and aluminium on the basis of valency. We are going to start with the first one, magnesium and phosphorus. Tell me, what is happening? Magnesium and phosphorus based on atomic size or radius. So they are third period elements. You can see magnesium, you can see phosphorus. What is happening? अच्छा, किसका smaller atomic radius होगा? This is, let me put it in this way. Smaller atomic radius. Is it going to be phosphorus or is it going to be magnesium, which is going to have smaller atomic radius? Phosphorus, phosphorus, phosphorus. I see a lot of you write about phosphorus. All right, yes. So as you go from left to right across a period, what is happening? Effective nuclear charge is increasing. Now, atomic radius is going to decrease. That means phosphorus will be smaller as compared to magnesium, or I can say magnesium has a larger atomic radius as compared to phosphorus. Let's move on to the next part after knowing this marking scheme. In this, all you need to write is magnesium has a larger atomic radius than phosphorus, and there you go, it will fetch you 1 mark. Alright, next, lithium and fluorine based on electronegativity. Quickly tell me this one. Lithium and fluorine based on electronegativity, which is the tendency to attract the shared pair of electrons. Which is going to be more electronegative. More electronegative. And I've given you a hint to solve this one. I've told you just look for metals and non-metals, you'll be sorted. Fluorine is going to be more electronegative. Alright, so left to right your nuclear charge is increasing, electronegativity is increasing, which makes fluorine is more electronegative than lithium. Lithium would probably want to lose electron and not gain, right? So yes, this is how your answer sheet should look like. Fluorine is more electronegative than lithium, and you will be given 1 mark for this. Finally, the third one, boron and aluminium based on valency. Try this one now. Based on valency, what do you think? You have boron here and you have aluminium here. So group 13 elements. Same. Aluminium has more valency, Prakhar is saying. Rest everybody is saying same. So let's explain, Prakhar, how the valency of aluminium is not more than that of borons. Over here, whenever a question of valency comes, the first thing is to know about the valence electrons. Okay. We have already discussed group 1 has 1, group 2 has 2, group 13 3, 14 4, so on and so forth, right? Now, based on the valence electron, you can easily get to know the valency. For group 13, obviously, you can see that it's easier to lose 3 electrons than to gain 5. So, valency is 3. Now, valency is 3 for boron also, it's 3 for aluminium also, which means they're going to have the same valency. So, Prakhar, if you've understood this question, give me a quick thumbs up in the comment section. I'm waiting for your thumbs up. I hope now you've understood why aluminium is not having higher valency. It's the same as borons, 3. Great, Prakhar has given a thumbs up to all of us. Let's see how we have to write this answer. So, valency of boron and aluminium is going to be same, which is going to give us this precious 1 mark. Moving on to the next question, and the next question is right in front of you. 2 compounds A and B have the same molecular formula, C3H6. If B is a cyclic compound, what do you have to do? You have to draw the structure of B and you have to identify the relation between A and B along with another thing, give reason. So when you read a question, please underline the keywords. Within a subpart, they're asking you two things. Identify the relation and give reason. Don't be in a hurry, guys. Don't be in a hurry to answer. Always read the question very, very properly. Otherwise, you know what will happen? You will just read the first part, mention the relation, move on to the next question. Don't do that. But anyway, we'll start with the first part. Since you cannot draw this over here, let me share the solution on the screen. So they are saying C3H6. 3 carbon atoms are there. 1, 2, 3. And B is cyclic. That means it's a ring structure, right? And hydrogen is 6. So 1, 2, 3, 4, 5, 6. There you go. C3H6. What's the name of this compound? Charvi says cyclopropane. Do we agree with Charvi? A lot of you are saying cyclopropane. A lot of you are saying yes, we agree with Charvi. Great. Alright, so there you go. This is cyclopropane C3H6. This is how the structure looks like. Draw this, you will get this 1 mark. Or maybe just free 1 mark, because the question is going, you'll find the question really easy, right? Alright, second part of the question says identify the relation between A and B, and you have to give reason. A and B. They are saying same molecular formula is there. Now tell me the relation quickly. Isomerism, isomers, structural isomers. Someone's writing Charvi OP. Isomers, structural isomers. What is A? There is no option here. Oh, someone's written, ma'am, it should be propene. I just missed the name. A को identify भी कर लिया है. Alright, so A is actually propene, right, and B is cyclopropane. So alkenes and cycloalkanes can be structural isomers, right? This is going to be the structure for both of them. C3H6, they have the same molecular formula. Clearly, they have different structures. So they are structural isomers. And you people have guessed this absolutely right. So in the exam, you have to mention two things. The first is the relation. Remember that they are structural isomers. And second is the reason, because they have the same molecular formula but different structures. So that's how this 1 plus 1, 2 marks will be in your pocket. Yes? Great, awesome. How many of you got this one right? Tell me in the comment section quickly. Quickly tell me in the comment section if you've got all the parts of this question absolutely right. Waiting for the interesting emojis that you people keep posting. Great, awesome. Good to know that so many of you have got this one right. Moving on to the next question. Okay, don't be scared looking at the length of the question. Usually, जो ऐसे questions होते हैं ना, they are the easiest. So, just read the question properly. A metal X combines with oxygen to form a compound XO. The oxide XO is soluble in water. How many electrons would be there in the outermost shell of the element X? To which group of the periodic table does the element X belong? Write the formula of the compound formed when X reacts with chlorine. It's a 3-marker. We'll be starting with the first one. How many electrons would be there in the outermost shell of the element X? Let me go back to the question once. They are saying XO. Class 9th में हमने पढ़ा था कि वैलेंसी से कैसे फॉर्मूला बनाते हैं. Just reverse it. कंपाउंड का फॉर्मूला आपको गिवन है, वहां से आप वैलेंसी निकालो. एंड ऑल्सो प्लीज नोट इट्स अ मेटल एक्स. दैट मीन्स एक्स इज गोइंग टू बी अ मेटल. कीप दिस इन माइंड बिकॉज आई एम गोना कम बैक टू दिस पॉइंट. So how many electrons would be there in the outermost shell of this element X? Let's see what your answer is. Just for the first part, guys, give me the answer in the comment section. 216. I can see all the numbers out there. I want one unanimous answer. Come on, you can do this. Let the chat box have just one single number written. all right, 2 पे लॉक करते हैं. Let's see. It's given X is combining with oxygen to form XO, right? X is a metal, that is a very important point given to us. Okay. Now formula XO is given to us, and for oxygen, we know that valency is 2, right? For X, we don't know what the valency is, but we know that the final formula is XO. That means it's cancelling, right? So it must be X2O2, this 2 and 2 getting cancelled, making it XO, which means for X the valency is 2, and there you go, you figured out the valency. Now, important point to note over here that we sometimes miss, right? X is a metal, right? And it has a valency 2. That means it's losing 2 electrons. Even non-metals can have a valency 2. As you can see, oxygen has a valency 2, right? But oxygen is gaining 2 electrons. That is going to be the difference over here. So, the number of electrons in the outermost shell of element X is going to be 2, because 2 valence electrons are there. Correct? 2 valence electrons are there. This is what you have to figure out. That is why in the question where it's written metal, that's a very, very important point. No silent mortal. You're giving the correct answer. Alright, so there you go. Valence electrons are going to be 2. That is the number of electrons in the outermost shell. And by writing 2 electrons, you will get 1 mark. Moving on to the next part. To which group of the periodic table does the element X belong? Kiss group ko belong kar hai, guys? Again, I want a quick reply, and I want a single reply. Same reply throughout. 2, 2, 2, 1. I saw 1 out there. 2, 2, 2, 2, 2. A lot of you are saying 2. Great, awesome. Thank you for giving me the same answer this time. Someone is writing 2 is equal to 1. Kuch bhi. Okay, so XO is soluble in water, that's been given to you, right? And oxides of only group 1 and 2 elements belonging to group 1 and 2, their oxides are soluble in water. Now, for group 1, number of valence electron is going to be 1. For group 2, number of valence electrons are going to be 2. And we know that number of valence electrons are 2. So clearly it's going to belong in group 2. So yes, you've cross-checked your answer as well. Great! Awesome! This is what you have to mention over here, that X belongs to group 2 of the periodic table, and you will get this 1 mark. Okay, it's a smiley face. Alright. Correct. Moving on to the last part of the question, which is very easy peasy. You are going to give me the answer. Write the formula of the compound formed when X reacts with chlorine. Quickly tell me, you know about the valency of X. Chlorine, you know the valency. Tell me the formula quickly. And Praveen has already answered. Before I could finish the question, Praveen has posted the answer. And now a lot of you are posting the answers. XCl2, MgCl2, XCl2, MgCl2, that's what I can see over here. Alright, so X and Cl, the respective symbols are there. For X, valency is 2, for Cl, the valency is 1. Just do crisscross, you will get XCl2. So well done, you have given the correct answer. Great, Srishti. Alright, so since the valency of chlorine is 1, X reacts with chlorine to give you this XCl2. See, this will not come as a standalone question. It will always be in a part. Most probably, okay. Yes. Jishin is saying Dhanyavad. Alright. Okay, so this is going to be a final answer, that XCl2 is what you need to mention to get this 1 mark. Moving on to the next question, what is a hydrocarbon? And you have to give one example quickly. What is a hydrocarbon, guys? Simple, simple. But yes, Such questions are coming in the exam. See, that is why I'm telling you, don't be scared of the board exam. Board exam के नाम से सब घबरा जाते हैं. When you look at the paper, you will understand कि सब कुछ cover किया, सब कुछ आपको हम already discuss कर चुके हैं. Contains only carbon and hydrogen. Okay. An example, methane, ethane, methane, ethane, propane. I think alkanes आपके favorite हैं. Okay, so when we talk about hydrocarbon, they are the organic compounds which consist of only carbon and hydrogen, right? So they are hydrocarbon. One of the examples we've picked up from there, put it over here, ethane. But yes, you can give any answer in this question, right? Any example. Now the second part of the question. Give the structural difference between saturated and unsaturated hydrocarbons with 2 examples each. What is the difference between a saturated and unsaturated hydrocarbon? And you know, if you feel question easy, पता कई बार क्या होता है? Easy questions में ही हम silly mistake करते हैं. Because we are kind of overconfident when the question is easy. We think we know it all and somehow we end up making a mistake. That happens, right? That's why we should not take even easy questions for granted. Saturated, single bond. Unsaturated, double or triple. Correct. Correct. So, hydrocarbons can be divided further as saturated or unsaturated. Saturated would contain single bond between carbon-carbon atom. Unsaturated would contain double or triple bond between carbon-carbon atoms. Correct, yes. Nice, good to know that. Alright, some examples of saturated methane, ethane, propane, you can give any example. Yes, hexane is also right. Now, unsaturated ethene, ethine, you can give a lot of examples out there. Yes, butane, correct. Great, Gyatish, I hope it was great. Lakshmanan, really soon. Propene, propine, correct. Alright, so there you go, that's the answer. But for this question, I want you to understand the marking scheme. Organic compounds, which consist of only carbon and hydrogen, are your hydrocarbons. And they asked you for an example. Mention both. This is half plus half 1. Saturated hydrocarbons that contain only single bond are basically single bond between carbon-carbon atom. They are your saturated hydrocarbons. Unsaturated would contain double or triple bond between carbon-carbon atoms. So again, half plus half 1. Half for saturated, half for unsaturated. I hope you can see this now. Yes? Alright. Coming to the example part now. 2 examples you have to give for saturated. That is your this half mark. 2 examples of unsaturated. That is for this half mark. This question has so many subparts. 2 line ka question hai, but so many subparts, and I hope you can see this is how basically we are bifurcating the marks. Yes, so don't miss out on anything. Understand they are asking 2 examples of saturated and 2 examples of unsaturated each, right? Great. Awesome. Let's see what the next question is. An element X is forming an acidic oxide. Its position in modern periodic table will be, if the pole appears, mark your answer there. In any case, I'll give you 60 seconds and your time has already started. Group 1, period 3, group 2, period 3, group 13, period 3, group 16, period 3. 4 options are being given to you. I'm going to underline the important keyword that is there in the question. An element X is forming an acidic oxide. Acidic oxide form हो रही है, आपको position बतानी है. Clearly all these, when they give you a group and a period number, that's a very specific position in the periodic table. That belongs to one element, right? I see a lot of you vote for one option, I'm going to put a smiley face right in front of it really soon. Great. Last 5 seconds left, guys, quickly. And time's up. So, most of you are saying it's option D. Let's figure this out. Alright, so this is the beautiful periodic table that we have, right? Metals are basically known to form basic oxides. This is in general, right? And non-metals, acidic oxides. As you go across a period, what is happening? Basic nature is decreasing. Basic nature of oxides is decreasing. Acidic nature is increasing. Down the group, there is not much change, right? Now, let's analyze each option one by one. Let's look at the position of each option. Group 1, period 3 is a metal. Which is this metal, guys? Quickly tell me. Let's see how well you know the periodic table. Group 1, period 3, which metal are we talking about? Quickly. Right now, you have to answer lightning speed से. जल्दी से बताओ कौन से metal की बात हो रही है? Sodium, 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 sodium. Correct. Basic oxide, right? Group 2, period 3. Quickly tell me about this now. Group 2, period 3, which is this metal. Let's see who's going to answer. Magnesium. What about group 13, period 3? This one. Group 13, period 3. Aluminium oxide was amphoteric in nature, right? So, if you get confused, go back and see which metal are we talking about. You remember we've done this in metals and non-metals also in term 1. Amphoteric oxide, correct. Aluminium oxide. Now coming to this, group 16, period 3, which is this element. Let's see. Sulfur, correct. So sulfur, non-metal forming acidic oxide, and there you go. That's your answer. You can easily cross-check using this as well. Yes? So see, the knowledge of periodic table will not go anywhere. वो आपको help ही करेगा हमेशा. Great! So if you've got this one right, if you knew all these elements, all the 4 elements, post 4 emojis in the comment section quickly. Quickly tell me that yes, you got this question absolutely right, and any such question, if given in the exam, you will be able to attempt correctly. Devarpan का नहीं आया सही, I guess. Most of you got it right. Three parts समझ आ गए. अच्छा, चारों different emojis. Great. Hey Priyesha, welcome. अच्छा, bulb जल गया. Great, awesome. Sujata is saying could not answer quickly, but I hope you got it right. That's more important. Great, great. All right. Awesome, guys. This is just making me actually believe that you will have a lot of confidence. All right, guys. We can also connect on Telegram now. So this is good news, right? You'll get the session updates there, homework questions, revision questions, session PDF, Sunday fun facts, so much more, right? All the updates would be there, especially the session PDFs that you've been asking for since a long time. The link is here, the link is there in the description box as well. So go ahead and join this. And of course, we've got you covered, guys. You people are working really hard. Yes, so be confident and yes, stay calm. That's really, really important. I can see आज आप लोग बहुत ज़्यादा काम थे. That's why you were giving the right answers. All right. As promised, we told you we'll keep coming up with amazing sessions. Now, the next session that we have is going to be a mega term 2 mentee quiz. So, it's going to be today only. That is 6th May, Friday at 7 p.m. guys. We will be meeting again at 7 p.m. Tell your friends about this. Let's have a quiz together. Let's have a final mentee quiz for chemistry. Yes, mega quiz together, and let's see how well you will be attempting this. Knowledge to hai. Now I want to check your speed. Knowledge is very much there. I could see that. But of course in mentee, speed is like the dominating factor, right? Yes, Praveen is super excited for this mega mentee quiz. Great. Alright, there's another link this time in the description box. It's for a feedback form. Go ahead, fill that form. It will just take you 30 seconds to fill that form. We want to know you better, right? So yes, we require feedback from you. So go ahead, fill that form as well. And another link for a free trial class. If you've not taken this yet, you can take this free trial class as well. And finally, don't forget to like this video, subscribe to the channel and hit the bell icon. Like this video right away and give me loads of thumbs up in the comment section if you've liked this. Yes, of course, it feels good when you encourage us. So yes, like this video quickly and let me see a thumbs up in the comment section after you've liked. Anvesha ne hands raise kar diya hai actually. Ki yes ma'am, I've liked this video. Let's see. Mahashi, Charvi, Lakshi, Abu Tahir. A lot of you are actually liking. Great. Sushila, Shreya. Awesome. I hope you've subscribed to the channel. Obviously, you must have hit the bell icon as well. If not, do it right away. We have another session at 7 o'clock. Correct. Yes. Subscribe to the channel. And of course, tell your friends about this. Let everybody be there for the mentee quiz. And together, let's learn in the most perfect manner. Great. Awesome, guys. Thank you so much for being there. Just be pepped up, charged up because a quiz is going to be there really soon. Mega quiz, mentee quiz. So, I'll see you there now. Keep practicing, keep learning till then. Take care. Bye-bye.